So we're going to start our final section, which is 15.2. It's about line integrals. So we're going to start by recalling some facts. So recall that a plane curve C given by R of t is going to be x of ti plus y of tj, and let's say t goes between A and B, is smooth when the derivatives dx dt and dy dt are continuous on the interval a to b and not simultaneously zero. So from this, we can then talk about a new term called piecewise smooth. A curve C is piecewise smooth when the interval A to B can be partitioned or broken up into a finite number of subintervals on each of which C is smooth. So let's look at our first example here. Let's find a piecewise smooth parameterization of the graph of C shown. So the graph is going to look like so it starts at the origin. Maybe I'll do this in blue. And then it's going to go to the point 0, 2, 0. It's x, y, z. And then it's going to go horizontally out to the point 1, 2, 0. And then it's going to go vertically up, straight up, to the point 1, 2, 1. So this C is really made up of three pieces, and I'm going to label them. The first piece was C1. Second piece, you should have arrows on them. The second piece was C2, and the third piece was C3. So really this piecewise, or this curve C can be broken down into three pieces, and each piece is really just a line segment. So this curve is really made up of line segments. So here, let's write down a parameterization of C1. Well, if you look at C1, you're moving along the y-axis, so x will be 0, and z will also be 0, but then y, if I let t go between 0 and 1, y ends out at 2t, so it'll be, or it ends out at 2, so y would be 2t. If I describe C2 now, and I'm going to let t be between 1 and 2 for this portion, the only thing that's changing is your x. Y stays the same, so y of t is 2, and z, your z component is always 0 there on C2. And so x starts off at 0, but if I plug in t equals 1, so I need to subtract 1. That will tell me x goes between 0 and 1. And then finally, C3. C3 is really, I'm going to have t go between 2 and 3 now. If I look at C3, the only part that changes is the z coordinate. So x stays 1 the whole time. Y stays 2 the whole time. And z, now it's going to be t minus 2, because z starts off at 0 and ends at 1. So you can describe this curve C by the following. You can describe it by 2t 2t j, where t is between 0 and 1. You can describe it by t minus 1i and 2j. That's where t is between 1 and 2. And then finally, for t between 2 and 3, you can describe it as I plus 2j plus t minus 2k. And if you look at each individual curve here, all of these functions right here tell me that C1 and C2 and C3 are smooth, which then tells me C is piecewise smooth. But here's my parameterization.